This is visking tubing. It's long been used in school biology practicals. It's semi-permeable, which makes it useful as a model of the human gut, which is what I'm going to show you in this demonstration. I'm going to fill a piece of tubing with a mixture of starch and glucose, and I should be able to show that over time the smaller glucose molecules migrate through it, whereas the larger starch molecules do not. So we need to soak the visking tubing in water for a few minutes, then it should be flexible enough to work with. You want to hold one end of the tubing open, and an easy way to do that is to use the end of a sawn-off syringe. So once that's in there, I'm just going to secure it with a rubber band. And I'm simply going to tie a knot at the other end of the tubing. And now I'm ready to add the starch and glucose to the tubing. So I'm going to just mix together some starch suspension, just 25 mils or so there, and some of this glucose solution. Now the concentration of glucose will affect the speed at which the results become visible. So obviously the more concentrated the glucose is, the faster that diffusion will happen and the quicker you'll see the final results to the experiment. So you might want to adjust the concentration and also the length of the tubing within the boiling tube that it's going to go in to fit in with the time that you want the demonstration to take. So I now have my mixture of starch and glucose. Let's just give that a little mix, and I'm going to syringe it into the visking tubing. So you probably want between 10 and 20 millilitres in the tubing. So a little bit more. I'm just going to clean the outside of the tubing by rinsing it with some water before I place it into a boiling tube and fill the rest of the boiling tube with water. You don't need to use distilled water here, tap water will be fine. Now the length of the tubing that you have in the boiling tube will also affect the speed at which the migration of the glucose happens. So something else to think about when you're trying this out beforehand. I'm going to take a sample straight away of each of those. So one from inside the visking tubing and one from the water surrounding the visking tubing. At this stage, you probably want to ask your students to predict which of those samples will contain starch or glucose. You can also ask them to remind you of how you test for the presence of those two molecules. So with this first sample from inside the visking tubing, I'm going to place a drop in my tile, and I'm actually going to put the pipette back inside the tubing there so I can remember which one's which. And the same with the sample from outside the tubing. So I'm going to label these two test tubes before I forget which one's which. So inside sample 1 and outside the visking tubing sample 1. So in order to test for the presence of starch in these samples, I'm just going to add a drop of iodine. So firstly the sample from inside the visking tubing, and yes, we can see that starch is present as we'd expected. And from the sample outside the visking tubing, we can see that there's no starch. Now in order to test for glucose, we're going to add some Benedict's reagent to each of these two samples and place them in a warm water bath. So just a good squirt of Benedict's reagent into each one of those test tubes. And I've just boiled the kettle, so a little bit of hot water into a beaker here. Don't need too much. And let's put these in here. Now this can take a minute or two to show up, but if glucose is present, we should see a colour change from the light blue here to an opaque orangey brown colour. While you're waiting for the Benedicts to react, you might want to remind your students that starch is broken down into glucose during the process of digestion. This allows the smaller glucose molecules to be absorbed into the bloodstream. So we can see this has now reacted. And what we have established here is that inside the visking tubing, at the start of the experiment, we have both glucose and starch present. And in the water surrounding the tubing, we have neither molecule present. Now, in order to show that over time the small glucose molecules will indeed migrate through the membrane, we need to give this some time. The exact time will depend on your practice run, but probably at least 15 minutes. So during that time, there are various activities you could be doing with your students. You might want to do a bit of work on explaining how a semi-permeable membrane behaves, and you can use demonstrations involving some loose netting, different sized balls in order to demonstrate that. Alternatively, you could have your students evaluate this as a model of the gut. The mixture of starch and glucose in the tubing here is a good representation of the different size molecules that are contained in our food. Those molecules are contained inside a tube, here the whisking tubing, and in our gut, the small intestine itself. The gut is also surrounded by blood, and in here, our tubing is surrounded by water. And it's a semi-permeable membrane that separates those two substances. In terms of differences, there are quite a few areas where this model falls apart. So firstly, the whisking tubing is very smooth, whereas the gut has folds, which increases its surface area. There are also active transport mechanisms in the gut, which help the movement of the molecules. Inside the gut, there are also enzymes present. So amylase breaks down starch into glucose. And you could ask students how they could maybe extend this model to show that, because I've simplified it by adding the glucose into here directly. So they might want to think about how the enzyme could be added to this setup to refine the model further. After enough time has passed, you're ready for the second round of tests. So once again, I'm going to take a sample from inside the whisking tubing, and my sample now from the water surrounding the tubing. Now you could ask your students to make a prediction at this stage about whether they think starch will be present inside or outside the tubing. We can see it's still present inside the tubing, but it's not present outside the tubing. Now let's test for glucose. So some Benedict's reagent added to each of those test tubes, and let's have a look and see if we've got any glucose. So the tests should now show clearly that glucose is present both inside and outside the whisking tubing, but starch is only present inside the tubing. How you decide to use this will depend on the learning outcomes you want for your students. Hopefully you've seen that doing it as a demonstration allows you to guide discussions and develop students' understanding. But you might feel that it's more important for your students to develop skills in manipulating this kind of apparatus or in performing standard tests. If that's the case, it can be easily adapted to a class practical.